In this video, we're going to talk about how to solve problems involving properties of exponents. So remember, we have this chart that tells us the properties of exponents. This is also posted in the course, so use this chart as you're working through the problems in this lesson. Remember that you talked about all of these properties back in Algebra 1, so this lesson is going to be a review. Remember this very important concept when working with problems that involve exponents. You're going to work with the coefficients separately from the variables. That's because the coefficients are going to follow the standard rules of multiplication, division, whatever's happening in the problem, but then the part with the exponent is what's going to use the special exponent rules. So let's start off with the product of powers property. If two terms with the same base are being multiplied together, you're going to add the exponents. So let's try simplifying this problem. So the first strategy, whenever we have problems that have coefficients and variable terms with exponents, we're going to separate the variables and the coefficients. So what that means is I'm going to take all of these coefficients, so we have 4, 2, and 3, I'm going to pull those out in front. Okay, so that's going to be 4 times 2 times 3. So then I'm going to combine the terms with the same variable. So I'm going to put the y cubed term with the y squared term. And then I'm going to put the x terms together. So we have x to the fourth and we have x squared. It's always a good idea to go back and double check and make sure that you've accounted for all the terms. So we have our 4, 2, and 3, and then we have our y cubed and a y squared, and we have our x to the fourth and x squared. So what I mean by working with the coefficients separately is this 4, 2, and 3, they're just going to get multiplied together. Okay, so we're going to do standard multiplication there. So 4 times 2 is 8. 8 times 3 is 24. So I'm going to leave that 24 in front. Now the terms with the variables and the exponent, I'm going to use the exponent rule. Remember the rule that we're talking about in these problems is that product rule. So the a to the m times a to the n equals a to the m plus n. So that means I'm going to keep the base the same. Okay, I'm going to keep the y, but then I'm going to add together the exponents. So I have 3 plus 2, which is 5. I also have my x terms, so I have x, that's my base. Then I add the exponents, 4 and 2, and that's 6. So that is the solution to this problem. So when you simplify, you get 24 y to the 5th, x to the 6th. You can also write this as 24 x to the 6th, y to the 5th, if you prefer to do that. So we also have what's called the power of a power property. So if a term with an exponent is raised to another exponent, you're going to multiply the two exponents together. So for example, if we have this expression, we're going to work on simplifying it using that power of a power property. Remember, once again, I'm always going to work with a coefficient separately. So I'm going to pull that negative 3 out in front, and this power, remember, goes to every single thing that's on the inside of the parentheses. So I have negative 3 to the 4th, and then I'm going to do my x, so I have x squared to the 4th, and then I have y to the 4th to the 4th. So this negative 3 to the 4th, that's just going to be like whatever our standard math rules are, okay? So to figure out negative 3 to the 4th, you can go to your calculator and enter the negative 3, make sure to put it in parentheses, and then use the caret button, and then do 4. So when you get negative 3 to the 4th, your calculator should tell you that that is 81. Okay, be careful that it's not negative 81. If you type it in wrong, if you don't use the parentheses and just use the caret, your calculator will do order of operations and tell you negative 81. That is incorrect because that's doing negative 1 times 3 to the 4th. That's not what we want. We wanted to do negative 3 to the 4th, and that's negative 3 times negative 3 times negative 3 times negative 3. So you can see those negatives will cancel out, so that's how we end up getting positive 81. So this is going to be 81. And then we have x squared to the 4th, okay? So here's where we need those exponent rules. So we have x squared to the 4th, so those are going to multiply together. 2 times 4 is 8, so we have 81 x to the 8th. And then we have y, and we have 4 to the 4th. So once again, we're going to multiply those two powers, so we get y to the 16th. So that is how you simplify this problem. So sometimes you have to combine rules. So sometimes there'll be more than one operation going on in a problem, and you'll have to use more than one exponent rule. So when we do this, we're going to use, once again, order of operations. Remember, order of operations tells us to do parentheses, then exponents, multiply and divide, and then add or subtract. So we're going to do the same thing when we're working with problems that involve exponents. So for example, if we want to simplify x squared y cubed squared times x squared y to the fourth. So you can see we have a power, right, which is an exponent, and we have a multiplication. Well, order of operations tells us that we have to do that exponent first. So we're going to do that then we're going to do the multiplication. Okay, so we're going to do this squared first. So that gives me x squared squared and then y cubed squared. And then we're going to leave this x squared y to the fourth alone just for right now. So x squared squared, once again, I use that product of powers property. So that gives me x to the 2 times 2, which is 4. And I have y to the 3 times 2, which is y to the 6th. And then I have this term, x squared y fourth, that I left alone. So now that I took care of the exponent, now I can do the multiplication. So when I multiply, remember, I'm going to separate the variables. So I'm going to have the x to the fourth, okay, times x squared. And then I have y to the 6th times y to the 4th. So now when I multiply, I'm going to be adding the exponents together. So you want to be careful when you're using more than one type of operation. Remember, you have different exponent rules. So when I multiply, I add. So I have x to the 4 plus 2, which is x to the 6th. And then I have y to the 6 plus 4, which is y to the 10th. And that is now my final answer. So you can go ahead and pause the video and try this example on your own. So in this example, once again, we have an exponent and we have a multiplication, right? So we're going to do the order that PEMDAS tells us, and we're going to exponent before we multiply. So I'm going to start off with this exponent of 4, which is going to go to everything that's on the inside of this term. So that gives me 2 to the 4th, and then I have x cubed to the 4th, and I have y squared to the 4th. Well, in my second term, I also have an exponent, so I'm going to do that exponent, which is going to go to everything within the parentheses. So that gives me 3 squared, x squared squared, and then y cubed squared. So now let's simplify this using our power properties. So 2 to the 4th, remember that's just going to be our standard math rule. So you can do that on your calculator, 2 caret 4. So that should give you 16. So that's going to be 16. And then I have x cubed to the 4th. Remember, the power of a power means they get multiplied. So I have x to the 12th. And then I have y squared to the 4th. So I'm going to multiply them, which gives me y to the 8th. And then now I have 3 squared. Well, 3 is just a coefficient, right? So I'm going to use my regular math rules. So I'm just going to do 3 squared. You can do it on your calculator. 3 squared is 9. So we have 9. And back to our power rules, right? We have x squared squared, so that's x to the 2 times 2, which is 4. We have y cubed squared, so that's y to the 3 times 2, which is 6. Okay, so now we've taken care of the exponents. We're going to multiply everything together. So when we multiply, we're going to pull out the coefficients first. So I'm going to pull out that 16 and 9, because those are just going to get multiplied together with like regular math operations. Then I'm going to put together the variables. So I have x to the 12th, and then times x to the 4th. And then I have y to the 8th times y to the 6th. Now I'm going to multiply. So I have 16 times 9. So you can just do that on your calculator. 16 times 9 should give you 144. So we have 144. And then now we're going to use our multiplication rule, right? So we have two terms being multiplied. We're going to add together the exponents. So we have x to the 12 times x to the 4. So we're going to add them together, which gives us x to the 16th. And then we have y to the 8th times y to the 6th. So that's going to be y to the 14th, right? Because we add them together. So we get 144, x to the 16th, y to the 14th. So we also have what's called the quotient of powers rule. So when you're dividing terms that have the same base, the exponents are actually going to be subtracted. So let's try simplifying this. So our strategy where we separate the coefficients and the variables is going to be the same as when we multiplied. It's just the rule is going to be different because we're using quotient. So once again, I'm going to pull out the coefficients, right? So I have 12 over 4. And then I'm going to put the a terms together. Okay, so we have a to the 6th over a squared. Then I put the b terms together, okay? So we have b to the negative fifth over b squared. And then we have c to the fourth over c to the third. Okay, so we separated everything out. So the coefficient part, we're just going to do regular division. Okay, so I just do negative 12 divided by 4. Okay, we'll have to worry about those exponent rules or anything there. So negative 12 divided by 4 is going to be negative 3. So now I have a to the sixth over a squared. So since I'm dividing, I'm going to subtract those exponents. Okay, so that's going to give me a to the 6 minus 2, which is a to the 4. Now we have b, so that's negative 5 minus 2. So negative 5 minus 2 is going to be negative 7. And then finally I have c, which is c to the 4 minus 3, so that's c to the 1. Remember that we don't usually write exponents of 1, so I'm just going to write 3a to the 4th, b to the negative 7, and then that c by itself. Okay, anytime you see a variable by itself, that means its exponent is implied 1. So we can also have the power of a quotient, just like we had the power of a product. So when you have something being divided and you're raising it to a power, that power will distribute to everything that's within the quotient. So let's try simplifying this. So if we're going to simplify this expression, you can see that everything is being raised to the third power. So that third power is going to go to every single term that is within that quotient. So when we do that, we get 2 to the third times s cubed to the third times t to the fourth to the third over 4 cubed times s squared to the third times t cubed to the third. Okay, so now with whatever coefficients we have, we're just going to do the regular math operations, right? So the 2 to the third, you can do on your calculator. 2 to the third is 8. So I have 8. And then I have s cubed to the third. Okay, so to simplify that, I need to use that power of a power property, which tells me that I multiply those two exponents. So s to the 3 times 3 times 3 is 9. And then I have t to the 4 times 3, which is 12. And that's over. Now I have 4 to the third. Okay, so remember, no exponent rules there, just using regular math on your calculator. So 4 to the third is 64. And then we have s squared to the third. So I'm going to multiply them together. S to the 2 times 3 is 6. And then we have t to the 3 times 3, which is t to the 9th. Okay, so now I've simplified it with the power rule. Now I need to use multiplication or division, right? Because remember, order of operations, we do exponents, okay, before we do division also. So that's why we did the third power before we divide everything. So once again, I'm going to separate everything out. So I have 8 over 64, okay, that's my coefficient part. And then I have s to the 9 over s to the 6th. And then I have t to the 12 over t to the 9. So 8 over 64, I can divide that, but since it's like a fraction, I'm just going to go ahead and reduce it, okay? So I can reduce this both by a factor of 8. So that's going to leave me with 1 over 8. So that's how I'm going to leave that. I'm going to write that as a 1/8. And then s to the 9 over s to the 6. So that's going to be s to the 9 minus 6, which is s cubed. And then I have t to the 12 over t to the 9. So that's t to the 12 minus 9, which is t cubed. So that is now my final answer. 1 over 8 times s cubed, t cubed. So now you can go ahead and pause the video and try this problem on your own. So once again, remember, I'm going to do order of operations. So I'm going to do the exponent before I divide, okay? So I'm going to start off by, just kind of distributing that third power to everything within the parentheses. Notice that the third power only applies to the numerator. So I have 2 cubed, x squared cubed, y cubed cubed over 2 and x squared y to the 4th, right? I'm going to leave the denominator alone. Okay, so the 2 cubed, I'm just going to do that on my calculator, right? 2 to the third power, which is 8. So I have 8. X squared cubed, remember I need to multiply those exponents, so I have x to the 6th. Y cubed cubed, y to the 3 times 3, so that's y to the 9. And that's over, once again, I'm going to leave the denominator completely alone. And so now I need to divide, okay? So when I divide, remember I separate everything out. So I have 8 over 2, okay? So that's my first part. And then I have x to the 6th over x squared. And then I have y to the 9th over y to the 4th. So 8 over 2, that's just going to be regular division. 8 divided by 2 is just 4. And then I have x, and then x to the 6th over x squared. So I'm going to subtract those exponents, giving me x to the 4th. Y to the 9th over y to the 4th. Once again, I subtract those exponents, giving me y to the 5th. So that is now our final answer. So what if we have a 0 exponent? Any non-zero number raised to the 0 power is 1. So if you have a to the 0, that's 1. Doesn't matter how complicated it is. If you have 705,455 x, y squared, and that's all being raised to the 0 power, that's still equal to 1. So let's try simplifying this. We have x squared, x to the 4th, y to the 0. So as soon as you see that y to the 0, you need to recognize that that's just 1. Okay, so then we just have x squared, x to the 4th times 1. So when we simplify this, the x squared and the x to the 4th, they're being multiplied, so we're going to add those exponents together. So we have x to the 6th times 1, which is just equal to x to the 6th. So what if you have a negative exponent? A negative exponent tells you that there's a reciprocal. So if you have a to the negative n, that equals 1 over a to the n. If you have 1 over a to the negative n, that equals a to the n. So I like to think about a negative exponent as if it was like being in the wrong place. Okay, so when you see the negative, it's like telling you, I want to move to the other side of the fraction. So if you have a negative in the denominator, it's like saying, I'm in the wrong place, move me to the numerator, and then it becomes a positive exponent. If it's in the numerator and it's being negative, if you move it to the denominator, it'll become a positive exponent. So for example, if we have x to the negative 3, that's basically the same thing as x to the negative 3 over 1. So if we move it to the denominator, that is going to become 1 over x cubed, which now we have that positive exponent. If we have 1 over x to the negative 5th, that is basically saying it wants to be moved to the numerator, right? So we move it to the numerator, so that's x to the 5th over 1, so that equals x to the 5th. So let's try simplifying this problem. We have 25x cubed y to the 4th over 5x to the 4th y squared. So this is a division problem, so we're going to separate everything out, right? We have 25 over 5, and then we have x cubed over x to the 4th, and then we have y to the 4th over y squared. So the 25 over 5, right, we can just do 25 divided by 5, which is 5. And then we have x cubed over x to the 4th. So that is going to be x to the 3 minus 4, which is negative 1. Then we have y. Y is raised to the 4 minus 2, so that is going to be y squared. So now we want to rewrite this problem using positive exponents, okay? So that x to the negative 1 is telling me it's in the wrong place. So it wants to be moved to the denominator. So what we can do is we can rewrite this as 5y squared over x. So when it moves to the denominator, it's going to become a positive exponent. So now you can go ahead and pause the video and try simplifying this problem on your own. So you can see here we have a bunch of terms that have zeros, right? So that x to the 0, I'm going to go ahead and that is 1, right? Anything to the 0 power is 1. That z to the 0, that is also 1. Okay, so now let's think about what we have left in this problem. So we have 4 times 1, so that's just 4, y to the 4th, z to the 12th, times 6x to the 10, y to the negative 20, and then that's just times 1, so we don't need to write that again. So now let's pull out the coefficients. So we have 4 times 6, and then we have, let's see, an x to the 10th. There's no other x terms. And then we have y to the 4th times y to the negative 20th. And then we have z to the 12th. So let's go ahead and do 4 times 6. Remember, that's just standard multiplication. So we have 4 times 6, which is 24. X to the 10th has nothing to combine with. And then we have y to the 4th, y to the negative 20th. Remember, when we're multiplying, we add the exponents. So we do 4 minus 20. So that's going to be negative 16. And then we have z to the 12th. Okay, so remember when I rewrite this, that the y to the negative 16th is telling me it's in the wrong place. So I'm going to go ahead and move it to the denominator. So I'm going to rewrite this as 24x to the 10th, z to the 12th. All the positive exponents are going to stay where they're at, and I'm moving that negative to the denominator. So in summary, remember, you're going to use these exponent rules that we talked about back in Algebra 1 to simplify and work with these problems.